A European space telescope revealed something that had been hiding in plain sight for over a century. A perfect ring of light wrapped around a galaxy so close, so well studied, that astronomers had been photographing it since the 1880s. Nobody had ever seen this ring before. Not in any photograph. Not in over 140 years of careful observation. And the way it was finally found is stranger than most people realize. This isn't some distant, abstract discovery. It happened in our own cosmic backyard. By the end of this video, you'll understand exactly why scientists are calling it one of the most unexpected finds of the entire mission. Let's start with the telescope itself. Euclid, launched from Cape Canaveral on July 1, 2023, was sent nearly a million miles from Earth on a 6-year mission with one central goal: to help scientists understand dark matter and dark energy, the two mysterious forces that, together, make up the vast majority of everything in the universe, despite the fact that nobody fully understands what either of them actually is. To do that, Euclid was built to photograph over 1 billion galaxies, mapping their shapes, positions, and distortions across enormous stretches of the sky in extraordinary detail. But before that grand survey could officially begin, Euclid's engineering team had to run through months of careful testing, making absolutely sure every instrument was calibrated correctly. Part of that process involved sending back sample images. And crucially, these early images were deliberately left out of focus. They weren't meant to be scientifically useful. They were simply meant to confirm that the telescope's basic systems were functioning as expected. If you're new to this channel, we dig into discoveries exactly like this one every single week. So make sure you're subscribed before we continue, because what happened next was never supposed to happen at all. In September of 2023, during this early testing phase, one of Euclid's archive scientists was looking through these blurry calibration images when something caught his attention. Hidden inside one fuzzy, out-of-focus frame was a faint but unmistakable hint of a very specific, and very rare, phenomenon. He decided to take a closer look. And what he found, once confirmed, left the wider research team stunned. The object at the center of this discovery is a galaxy called NGC 6505, sitting roughly 590 million light-years away. In cosmic terms, that's remarkably close, practically next door compared to the billions of light-years separating us from most of what Euclid was designed to study. This particular galaxy wasn't some newly discovered mysterious object, either. It had been photographed by astronomers since the 1880s, studied and catalogued for well over a century, appearing in countless surveys and observations long before Euclid ever existed. And yet, wrapped around its center, Euclid revealed something nobody had ever documented before: a nearly perfect ring of light encircling the galaxy, formed by a phenomenon called gravitational lensing. This effect happens when a massive foreground object, in this case, the galaxy NGC 6505 itself, bends and warps the light coming from a much more distant galaxy sitting almost perfectly behind it from our point of view. That bent light gets stretched and curved by gravity into a glowing circular shape, known to astronomers as an Einstein ring, named after the theory of general relativity that predicts exactly this kind of gravitational distortion. Here's the detail that genuinely surprised even veteran astronomers on the team. Einstein rings require an extremely precise cosmic alignment to actually appear. One galaxy sitting almost exactly in front of another from Earth's exact vantage point, with the geometry lining up closely enough for the light bending effect to become visible at all. That kind of alignment is rare enough on its own. Finding one around a galaxy that had already been studied so thoroughly for more than 100 years made it even more unexpected. One of the lead researchers on the discovery pointed out that only the exceptional resolving power of this particular telescope finally made the ring visible, something that had apparently gone completely unnoticed through over a century of prior observation using less capable instruments. If discoveries like this one, something hidden for more than 100 years, finally revealed by accident during routine testing, are the kind of thing that fascinates you, do me a quick favor and hit that like button. It genuinely helps this channel keep making videos exactly like this one. Scientists on the team have described why finding an Einstein ring this close to Earth actually matters scientifically, beyond just being a beautiful and unexpected image. Most known gravitational lenses sit billions of light years away, making detailed follow-up study extremely difficult given how faint and distant they are. A lens this nearby, in comparison, gives researchers a rare opportunity to study the effects of gravity on truly enormous scales, with far greater precision than distant examples typically allow. It becomes something close to a natural laboratory for testing whether Einstein's central predictions about gravity continue to hold up exactly as expected, even under these extreme astronomical conditions. This wasn't the only surprise Euclid delivered, either. In March of 2025, the mission released its first major batch of survey data, including early previews of what scientists call its deep field regions, small patches of sky that Euclid stares at for extended periods to capture extraordinarily faint and distant objects. Within that initial release alone, researchers identified hundreds of thousands of galaxies of wildly different shapes and structures, along with roughly 500 additional gravitational lens candidates, discovered using a combination of artificial intelligence analysis and contributions from citizen scientists sorting through the enormous volume of imagery. That number is expected to grow dramatically as the mission continues. Scientists working with Euclid estimate that by the time its major cosmology data release arrives at the end of 2026, the mission will have identified roughly 7,000 strong gravitational lens candidates. And by the end of its full survey, somewhere in the order of 100,000 galaxy-scale lenses, nearly 100 times more than astronomers had ever cataloged before this mission began. Each one of those lenses offers scientists a fresh opportunity to study the distribution of dark matter, an invisible substance that makes up roughly a quarter of the entire universe, yet remains completely undetectable except through its gravitational effects on the light and galaxies around it. More recently, in July of 2026, Euclid delivered yet another set of unexpected results. This time, reaching back further into cosmic history than almost anything previously observed. Researchers analyzing Euclid's survey data identified 31 ancient quasars, extraordinarily bright objects powered by supermassive black holes, actively feeding on enormous amounts of surrounding gas at the centers of very young galaxies. 2 of these quasars turned out to be the oldest ever confirmed, with light that began its journey toward Earth more than 13 billion years ago, from a period when the entire universe was only around 670 million years old. Finding quasars this ancient and this bright in numbers scientists hadn't expected to see so early in cosmic history raises real questions about exactly how supermassive black holes managed to grow so massive so quickly after the universe began. It's a mystery that echoes across multiple different telescopes and missions studying the early universe right now, each one turning up early black holes and early galaxies that seem to have formed and grown faster than existing models comfortably explain. What ties all of these discoveries together? The accidental Einstein ring, hiding in plain sight for over a century, the hundreds of thousands of newly catalogued galaxies, and the unexpectedly ancient population of ballooning black holes, is a simple but powerful idea. Sometimes the most significant discoveries in astronomy aren't found by searching directly for something specific. They're found by simply looking more carefully with better instruments at places astronomers already thought they understood. NGC 6505 is the clearest example of that idea in this entire story. It sat in plain view for well over 100 years, photographed repeatedly by generations of astronomers using increasingly capable telescopes, and none of them ever noticed the ring of gravitationally bent light wrapped quietly around its center. It took Euclid's specific combination of wide field coverage and sharp resolution, deployed almost by accident during a routine calibration test, to finally reveal something that had genuinely been there in plain sight the entire time. That raises a genuinely exciting question for the rest of Euclid's mission, which is still only in its early years. If a galaxy this close, this thoroughly studied, and this well photographed could still hide something this significant until 2023, what else might be sitting quietly, undetected, scattered across the roughly 1 billion galaxies Euclid is expected to eventually observe? Scientists working on the mission have been candid about the fact that they genuinely don't know the full answer yet. And that uncertainty is part of what makes the years ahead of this mission so worth watching closely. It's worth pausing here to really understand why this particular Einstein ring caught the attention of researchers so quickly, given that Euclid's calibration images were never meant to be scientifically useful in the first place. Early testing images like these are typically discarded or ignored once engineers confirm the basic hardware is functioning correctly. They're the equivalent of a photographer taking a few quick out-of-focus test shots just to make sure a new camera is working before the real shoot begins. Nobody expects those test shots to contain anything meaningful. The fact that a genuine, rare astronomical phenomenon was sitting inside one of these throwaway calibration frames is part of what makes this discovery feel almost accidental, a happy collision between careful human attention and sheer cosmic luck. That kind of careful attention matters more than people might assume. Euclid archive scientist Bruno Altieri, the researcher who first noticed the telltale hint of lensing in that blurry frame, wasn't running a dedicated search for Einstein rings at the time. He was simply reviewing test data as part of routine mission operations. Spotting a faint circular distortion inside an out-of-focus image and recognizing it as potentially significant, rather than dismissing it as noise or an imaging artifact, required exactly the kind of trained eye that comes from years of experience studying exactly this type of phenomenon. Once he flagged it, the wider research team moved quickly to confirm the finding using properly focused follow-up observations, ultimately verifying that this genuinely was a rare nearby Einstein ring hiding around a galaxy nobody expected to reveal anything new. This entire episode also highlights something important about how modern astronomy actually works today. It's rarely just about a single telescope pointed at a single target. Confirming and studying the Einstein ring around NGC 6505 required combining Euclid's own data with contributions from researchers across multiple institutions, cross-referencing historical observations of the galaxy stretching back over a century, and applying modern computational modeling to confirm that what they were looking at truly was a gravitational lens, and not some other, less exotic explanation. That kind of collaborative, methodical verification process is exactly why scientists were confident enough to publicly confirm the finding rather than dismiss it as a fluke or an instrument error. There's also a broader scientific payoff buried in this discovery that goes beyond the thrill of finding something unexpected. Because NGC 6505 sits so close to Earth in cosmic terms, researchers can study this particular Einstein ring with a level of detail that's simply impossible for lenses located billions of light years away. Distant lenses tend to appear small and faint, limiting how much detailed information scientists can actually extract from them. A lens this close, with the background galaxy's light clearly wrapped around a well-studied, well-understood foreground galaxy, gives astronomers an unusually clean and detailed opportunity to precisely measure exactly how much mass, including invisible dark matter, is concentrated within NGC 6505 itself. That kind of precise measurement, tested against a nearby, thoroughly documented galaxy, offers a rare and valuable check on how well our current understanding of gravity and dark matter actually holds up under close examination. Taken together, these threads point toward the same broader theme running through this entire mission. Euclid wasn't specifically designed to hunt for lucky accidents hiding inside blurry test images or to stumble across rings of light around galaxies humanity has already photographed for well over a century. It was built to systematically survey enormous portions of the sky with exceptional precision. And, as a direct result of that broad, careful approach, it keeps finding things nobody was specifically searching for. The deliberately blurry calibration image containing NGC 6505's hidden ring is really just the first, most striking example of a pattern that seems likely to repeat many more times before this mission concludes its full survey years from now, quietly rewriting small pieces of what astronomers thought they already fully understood about the sky above us. If something hiding in our own cosmic backyard could go unnoticed for over 100 years, right up until the telescope built specifically to hunt for far more distant mysteries stumbled onto it almost by accident. What does that tell you about how much of the universe might still be sitting quietly in plain sight, waiting for the right instrument to finally notice it? Drop your thoughts in the comments and let me know what you think Euclid might stumble onto next as its survey continues expanding across the sky. If this story pulled you in the way it pulled me in while researching it, hit that like button. It genuinely helps this channel keep telling stories like this one. And subscribe if you haven't already, because Euclid's full cosmology data release is coming later this year, and when it arrives, we'll be covering exactly what it reveals. 500 million light-years away, a ring of bent starlight sat quietly around a galaxy humans have been photographing since the 1880s, waiting patiently for over a century, until the right telescope finally looked closely enough to notice it was there all along. Like, subscribe, and share if you want more stories about the universe's biggest surprises. Thanks for watching.
If you enjoyed this video, please like, subscribe to Palsa Lab and turn on notifications so you don't miss our latest uploads. At Palsa Lab, we explore space, science, astronomy, AI, and emerging tech, bringing clear explanations and fascinating discoveries. Have a question or idea? Drop it in the comments. Stay curious, keep exploring, and thanks for watching. See you next time.